a television repairman, okay, finds that the time spent on his job has exponential distribution with mean of 30 minutes. Okay, exponential distribution time which to be required to complete the repair of a television is they given as 30 minutes. If repair sets in order in which they come in, and if arrival of set of follows the Poisson distribution is approximately with an average rate of 10 per 8 hours in a day. Okay, whatever the customer, those are arriving in a particular day. If you are considering 8 hours, then there will be average rate of 10. Okay, that is the value. Then expected, they asked you what is the repairs expected idle time each day. Means how much hours he will be idle without having any service. How many jobs are ahead, the average just brought in. Whatever the work is to be required to complete in that particular task, we have to make the evaluation. Okay, in this, what the parameter they provided? Two parameters they have provided. Okay, what are those parameters? One is lambda, another one is the mu. What is that lambda? Lambda itself is the average number of customers being served per unit time. Not mu is the average number of customers being served per unit time. Lambda is the what? The average number of the customer arriving per unit time. Okay, in this numerical they have provided both the values. Okay, one is 30 minutes of the exponential rise with respect to that completion of the work, that to be taken as the lambda, what the average time which to be required to complete that particular task, which is to be complete in the particular duration of the time. Okay, that itself is called as a mu. Then what is lambda here? What is the work which is to be required to complete? Okay, they are given, that is 10 per 8 hours in a day. Okay, from those data we are going to get, okay, lambda is equal to 10 by 8, then mu is equal to 1 by 30. Okay, if I taken that into subset of 60 means, then it will become into 2 set per hour. Okay, this is the what the data what they provided. Okay, once you read that question properly, then you have to write the solution for the same. Okay, this is what the data which is to be required to complete the work. Okay, in this television, the whatever the data they provided, in this lambda they provided. Lambda is equal to 10 by 8, which is equal to 5 bar 4 set per hour. Okay, then similar to that, they are mentioned in 30 minutes. But I want in terms of hour. Okay, so that 1 divided by 30 into 60, which is equal to 2 sets per hour. So that you have converted this. All of you got it now? Lambda. Okay, this is the 30 minutes time duration what they provided. Okay, corresponds that the rate at which we are going to complete the task. Okay, that itself is the subset. Any doubt? Note it down this. Okay, this will be got it from the given data what they provided. What you have to evaluate? They asked you to make the expected time which to be required to reach with respect to the requirement of the time to complete that repair. That you have to make the evaluation. All of you able to listen me now? Raise your hand. Okay, the expected idle time of the repair each day, the number of hours for which repair man remains busy in 8 hours. Okay, that you have to evaluate. Okay, copy this. These two. Once you copied, you raise your hand. Once you copied, you can raise your hand. Okay, here they are mentioned. What is the repairman expected idle in each of the day? Okay, that is what we valid. For that, we know the lambda value, we know the mu. Okay, what is that? The expected idle time for the repair of each day is equal to the number of hours for which repairman remains busy in 8 hours. Okay, it's to be given by 8. We know the lambda, that is lambda divided by mu. Okay, we know these values. Okay, so that if you are going to substitute the lambda value and the mu, okay, how much time duration he will be remains PG. We will come to know about it. Okay, to complete his task. Then what the time is to be remains is idle, that you can evaluate. Because in a day he will work for 8 hours. Then we know the time of the traffic which to be required to complete that particular task which to be given for the repair. Then I can make the evaluation how much time duration he will be idle. Okay, that is 8 is the number of hours into lambda by mu. Okay, then here 5 by 4 divided by 2. Okay, 4 into 2 is 8. Then 5. 8 into 5 by 8 equal to 5 hours. It means to repair a TV, okay, in a day, how many hours you will take? 5 hours. Based on the customer arrival. Okay, what is the idle time? In a day, he will work for 8 hours. 8 hours minus 5 is what? Is the remaining idle hour. Is this clear? What I am writing on screen is visible, ma? Raise your hand. Okay. Anybody having any doubt, you can ask. Copy this. Okay, this is the what? The idle time which to be there for the repair man. Copied? Once you copied, you can raise your hand. Okay. Next, second is what? The expected number of TV sets in the system. Okay, means the average value we want. Okay, that is E of LS. Okay, which is equal to lambda divided by mu minus lambda. Okay, because we know the lambda value, we know the mu value. Then you are going to substitute all those values here. Okay, that is lambda is 5/4, mu is 2, then 5/4. Then you will get 5/3. Okay, which is approximately equal to 2. What's that 5/3 value? Okay, 1.66. Okay, which is approximately equal to that of 2. Okay, 2 TV sets to be done with respect to that particular service menu. All of you got it? How to make the evaluation with respect to the time what they provided corresponds that provision. What is the subset which is to be required to complete that particular task? Anybody having any doubt, you can ask.